Good evening, everybody, and welcome. My name is Richard Williams. I'm a Pro Vice Chancellor here at the University and head of the College of Engineering and Physical Sciences. And it's a great pleasure to welcome you to one of our distinguished lectures and to one of our very distinguished lecturers. We started this series of lectures with the objective of seeing how some of the very best science was being applied at the extremes of engineering. And tonight, our lecture is really talking about applying science to the extremes of engineering our age and our durability. So it's a great pleasure to welcome Professor Seeram Ramakrishna from the National University of Singapore. Seeram is a friend to the university for some years, and he's also a fellow of the Royal Academy of Engineering in the UK as one of the honoured international fellows. So let me tell you a little bit about Seeram, if I may, to introduce you. Seeram is director of the Nanofibers and Nanotechnology Centre at NUS, and he's a professor of materials engineering, and in fact based in the School of Mechanical Engineering at NUS. A few of you here I know his work. He's one of the world's most highly cited researchers. He's on the highly cited list, and in the 2014 Thomson Reuters recognized most influential scientific minds. So, and what does that mean? Well, it means that he's written over 6 books, including one called The Changing Face of Innovation, and over 700 ISI-listed journals that have received over 39,000 citations. And for those of you into statistics, that means he has an H index of 92, which is pretty good. He's on the editorial board of 10 international journals ranging across disciplines of science into engineering. Seeram received his PhD in the UK from Cambridge and then undertook other management training at Harvard. And he's known globally for his global mind and the way in which he addresses global issues. And I think we shall get a taste of that tonight, relating to his pioneering work on engineering nanofibers for regeneration of tissues, harvesting of sunlight, and treatment of water. So in terms of his academic career, he's been a leader. He's been Vice President for Research Strategy. He's been Dean of the Faculty of Engineering. He's been Director of Enterprise, all of these at NUS. And he's the founding chairman of the Solar Energy Institute of Singapore. He has a passion for seeing research excellence across the globe. And as a consequence of that, he's been working with a number of the world-leading universities across Asia, India, and the USA. His global leadership includes founding the Global Engineering Deans Council. He's Vice President of the International Federation of Engineering Education Societies and a board member of the Asia Society for Innovation and Policy. And Seeram is elected International Fellow of several professional engineering institutes and academies. So, because as you will see, I think he's also a very interesting thinker. He's an op-ed columnist and regular speaking at meetings facilitated by UNESCO, the World Bank, the Organization for Economic Cooperation and Development, and various governments and universities. So it's really good to have a speaker that connects, who has a great pride in science and engineering and how the two are joined together, and a commitment to developing the engineering profession around the world. So please join me in welcoming Seeram to give this lecture.
Professor Williams, thank you very much for the kind introduction. More than that, for organizing a nice weather for me. It was so bright, and today is a wonderful weather, and I'm delighted to be here. And good evening to all of you. If we ask ourselves, what are the most challenging questions the humanity faces, one among them would be, almost no one among us know how long we actually can live, or how long we live. Nobody can predict. So while we cannot predict that, we know that we all change with time, with age, And we also know that science and engineering-based advancements are helping to improve our quality of life. So the topic I chose today is pathways for living beyond 100 years. And a topic like this would have a scientific dimension as well as a social dimension. So bear with me to take you through both the social dimension as well as scientific dimension, which I'm involved much more deeply. Let me begin by introducing to you Singapore. I know some of you been there, some of you heard about Singapore, but many of you probably only heard about it through the friends or through the media. So it's a British artist who came to Singapore last year, Stephen. He has an amazing gift, and he sees the place and he memorizes it and he sketches it completely with one look. So he came to Singapore, he went around Singapore, he had an aerial view of Singapore, then he started drawing it. What you see there is actually his sketch. He beautifully sketched from his memory. It's amazing. And that to come from a British artist, and it's impressive. So in a photographic way, if you take a camera, which is easier for all of us, since we don't have a photographic memory, we take a camera, we shoot it, that's how it looks like. That's a typical Singapore. The same image, but captured in a photo. And what we got there is right on the top here, it's a hotel. It's a very tall building, more than 100 floors. On top of that we have a very large swimming pool. We are talking about ageless living, right? For healthy living, swimming is necessary. And of course, swimming with a panoramic view is even better, right? Would you agree? Good. So what that means is you have to make a journey to Singapore. Right? So that's in case you feel you have to fill your time, not just swimming alone. We have beautiful domes. Inside we have a tropical forest and flowers. So it's a really beautiful inside, and you could see this rainforest. They've been recreated in a nice condition, so you actually can see them in a comfortable way. And you still have time. In the evening, you can have a nice walk through these gardens. These are completely artificial gardens built on a reclaimed land. So it used to be sea, but it has been filled, and it has been all this lovely, nice-looking tall trees, which are ecologically designed. So they're meant to create a positive environment, a positive effect on the environment. So it's really beautiful to see in the evening. And of course, it's not all about the buildings. We are now making every effort to make Singapore as a smart and green Singapore. So there would be a lot more initiatives to make the whole place smart and green. So this is an article I wrote for Singapore media, how Singapore might be transforming itself in the years ahead. That's available on the website, and my copy of slides would be made available to you. Should you be interested, you can look at that. So while that part of there is another information about Singapore. While I'm coming for my long flight from Singapore to Birmingham, so I chanced upon this Economist article, and it says, this year, Singapore is the most expensive city on the planet. So it has become the most expensive city on the planet, according to the EIU, Economic Intelligence Unit. That's what they say. So we switch from a basic introduction about Singapore to the topic of the day. So when this topic was proposed to me during a conversation with Professor Williams, I've been thinking about it, and I've been asking people Whoever sits next to me on the plane, I ask them this first question. When I meet a stranger at the train station or somewhere, out of blue they hear a question from me, how long would you want to live? The first thing, they have a very strange look at me. Who is this character? And why would he ask me such a personal question? But once I start talking to them, believe me, they send me an email, this is the most insightful discussion I ever had in my life. So I had this experience all the time. I've been doing this around the world, asking these questions. I had a varied answers. For example, people say, I want to work 10 years, live retirement plus 10 years. Others would say 80 years. Others would say 90 years. Others say 100 years. Someone says 110. Someone says forever. He wants to live forever. And of course, most people would say, as long as I'm healthy, as long as I'm independent. That would be the common answer, would say. So now the question is, what motivated them to answer that way? You look at this one. Those who said, I want to live for 100 or forever, more or less they are prompted by the thinking, they want to experience the world, every aspect of the world. So they believe they need a long time. Some say, I want to see grandchildren, great-grandchildren, so they want to live longer. Of course, some of them has a one-life concept. That means there is only one life. After that, we don't know anyway. So since it is only one life, let's live as long as we can, right? So that's what it shaped. Those who spoke more in terms of the lesser number of years, will I still look good? Will I still look beautiful and handsome? That was their concern. Some of them felt, will I be healthy? Some of them said, what's life after losing family and friends? And some of them actually have a multiple lives concept. That means they feel there is a continuity of life. It's just a phase. After that is another life and another life. So they have that thinking that shaped their mind. And some say, do I have to go back to the university again? University of Birmingham. That's the question, of course. And I had to learn again, and do I have to work long hours? Some even consider, is there an expiry date for marriage? Right? So you could see the wide spectrum of considerations that go into a mind in addressing this question. Have you seen Alice, the movie? Still Alice? Got an Oscar award this time. I guess you are all very studious. Nobody goes to the movies here, right? Right. Anyway, I also didn't see it, but I was watching the Oscar award, and that time I was listening to what Julianne Moore said. She said, I want to live 5 years more than my husband. Right? I thought it was a very interesting way. Then later on she said, of course she acted as an Alzheimer sufferer role beautifully in that particular movie. And the reason she said that is her husband is 5 years younger than her. So she wants to live 5 years more so that she can take care of him, who is already suffering with one of the mental condition. So that's the reason what she said. So you could see what shapes our minds. And of course, when I landed in Birmingham airport, of course, the immigration officer would ask me, what are you here for? I said to him, sir, I'm here to give a lecture. And he said, what is the topic? I said, how to live beyond 100 years. And he was smiling. He literally smiled. And he said, why on the earth do you want to live 100 years? I took the opportunity. I said, okay, you're my man. Let me ask you the question. So I turned around and I said, can I ask you a question? How long would you want to live? And his answer was, I want to live 1 day longer than my wife. It's a beautiful answer, really beautiful answer he made. That's what happened when I landed at the Birmingham airport, the immigration officer. So again, a variety of things. But as a scientist, as engineers, you have another reason why you want to live longer. Here is an analysis of how long it takes for you to get a Nobel Prize between your fantastic discovery to the time it takes to get the Nobel Prize. Here is the physics, chemistry, physiology, and medicine. 50 years ago, not much time, 10, 15 years' time, you would get that prize. Nowadays, it takes anywhere 30 to 40 years from your breakthrough. So we had a wonderful scientific breakthrough, but to get the Nobel Prize, on an average, you've got to wait 30 to 40 years, right? So there is a projection now, 2100. If you ever dream of getting a Nobel Prize, on an average basis, you better live up to 100. This is an analysis put together, and they analyze the data about how long it takes to get a Nobel Prize. So all those people who are desiring to receive the Nobel Prize, please try to live up to 100, so you have the chance to receive the Nobel Prize too. Yeah? So we have more than one motivation why one should aspire to live longer. So there's also other reason. The life expectancy of the world, the human beings, for a long time has been below 50 years. And now it has gone up last 100 years. It has inched up to 70 and 80 in certain countries. So there is a projection by 2050, the worldwide, the longevity could be anywhere between 70 to 90 years. So living up to 100 itself is considered a distinction. The reason is simple. In the past, the average lifespan was shorter because of the infectious diseases, poor hygiene and sanitation, and natural calamities. Now we figured out how to protect ourselves from calamities. We know how to protect ourselves from the diseases. So somewhat it has helped us to live longer. But there are new issues: obesity, stress, lifestyle, which is also now has a dampening effect on the longevity of the people. So if you look at that around the world, the longevity is not uniform. Some countries like UK, much longer, like Japan, where other countries like the others that are below 50, below 60 years. So it is quite different in different parts of the world, how long on an average they live. And also I picked up this magazine on my long flight. The Time magazine recently released, it said, this baby can live up to 142 years. That's what it says. So of course I read that article. It's very well articulated. And it looks like serendipity, because whatever I'm going to say is actually there in that article. Somebody wrote it, and I'm going to repeat some of those things where I also have a similar conclusion. There are many other books, on aging. And then also you come across a wide literature about how to live longer with health. And there are lots of articles. I think one of the other reasons why the longevity has gone up is a successful campaigning against smoking, right? So most people in the recent years, they are less smoky compared to, say, the previous generation. So that has helped immensely. The other one, alcohol consumption also. It is much more refined nowadays compared to the previous generations. That helped. And then, the UK cancer research also talks about the effects of alcohol and how does it accelerate certain forms of cancer. So that's clearly evident. And then, of course, there's a lot more attention now on the processed food. Some of the ingredients, packaging materials has an influence, carcinogenic in their nature, and there's a lot more attention and awareness among the people. So this is again contributing to the increasing longevity from 50 years to, say, now 70 to 90 years. Yeah? There's also lots of other information, but one could say a positive sum of relationships apparently increases the lifespan by 10%. So you focus on increasing positive relations with your family and relatives, friends, that would probably contribute to the longer life. So far what I told you is the social dimension, general information. Now I take you to my own understanding by talking to the experts, plus my own research. What you see there is my photo with Professor Wallace Fole. He's a Scottish man, lives in Singapore. I was giving a talk on infectious, anti-infection drug delivery methods at his eye institute. He walked up to me and said, "Seeram, can you guess how old I am?" I thought he was probably some 70 plus. He just started laughing and he said, "I'm actually 93. And he's working at a Singapore Eye Research Institute at the age of 93. Yeah. And so I said, I better have a picture because I'm giving a lecture. I could use this picture to show to the others. So you know what he told me for his secret? Good genes, moderation in everything. That means you do whatever you like to do, but you do it in a moderation and active both physically and mentally. But he also said one thing, which is quite cheeky, is don't see the doctor. He himself is a doctor, and he tells me quietly, don't see the doctor. So, well, that is a different font, different color, so you choose whether you want to follow that, right? And of course, another Scottish gentleman, he wrote a book in 1807, almost 200 years now, about longevity. He spoke about lemon balm. If you take that in your breakfast time, apparently it gives you a better life. And if you see me today lunchtime, I was asking for lemon balm in a cafeteria. Of course, I didn't get that. I got a red berry tea. Oh, so I did a serious going around to find out so that I'm well prepared to give this lecture. So I went down to India, and this is a gentleman, he's 108 years old. And I met him. You can see the evidence that I met him. So it's almost a selfie. So according to Indian philosophy, full life means about 120 years. And he said, what's his secret? Work is worship, eat less, basically. So he works very hard, but he eats less than what he needs, and that's it. That's what he told me. I was not satisfied. I better check other cultures. So I went to China. So here is a professor, he's a neurosurgeon in Hong Kong. He said, I also don't have an idea, but let's go to around the island, let's find it. So there's a temple in Hong Kong. It's called Longevity Temple. And there's a bridge in front of the temple. You cross the bridge and you gain 3 days of extra life. 3 days. Once you cross, you get 3 extra days. Can you imagine how many times I walked? Right? So I'm greedy. So, but let's bring that in the context of what do we know. Women live longer than men. Again, this is changing now. Actually, men are almost living at the same time, same length of period. Reason is, in the last 20 to 30 years, women are also exposed to the work stress because they are working. The stress associated with the work is also taking a toll on them. So that's why they no longer have the edge in terms of the longevity. The recent statistics suggest women and men, they almost live almost similar length. While we say we have a biological age, which is a single number, body parts age differently. So I may have my lung much younger or older than my own age. So same way other parts of our body. And one of the causes of cancer is bad luck. It's again scientifically proven. And genetics account about 30% of the longevity. And then we know there's a lot more molecular biology research in terms of reactive oxygen species, telomeres, and SIR genes, which are involved in the longevity of the human beings. So there's a lot of literature out there which talks about it. There's also another study which talks about if you're born when the sun is very feisty, apparently you live shorter than when sun is calm. So if you're born in that kind of period, you are exposed to less amount of UV radiation, so obviously you have a longer lifespan. That's what the Norwegians say that. So I started looking at the creatures, and it's wonderful. The natural creations, hamsters, they only live 4 years. Fireflies is only 24 hours, as short as that. Of course, human beings much longer. Then you look at the other ones. Here is, among the Chinese, koi fish is very popular, is because koi fish known to have a long life, 200 and plus years. And you have tortoise living up to 250 years. So you see why they have this koi fish in the ponds and at homes is a sign of they're desiring to have a long life, or a wealthy life. So the clam would probably have 500 years of life. So while we look at all those creatures, you look at the human creature, more or less this is the kind of change we go through. So I put that into a chart where what are the subtle changes that actually happens in all of us, almost every one of us. So you could start, say, up to, say, 20 onwards, we stop growing in height, and then you have a whole series of onset of these issues. It does not mean they happen in the same sequence, or everyone has the same way it happens, but more or less, if you pool the information on a statistical way, you would start seeing that kind of subtle changes in all of us. So all that requires us to have some progress in science and engineering based advancements. You're able to see this one? Okay, so it's pretty much to set the stage why we need further advancements in science and technology to have a healthy and wealthy life. So that information, I put this in a very simple graph. It's not scientific. Tissues, organs, and cells and systems in the human body. Some sort of initial phase is growth. Then you have a dynamic equilibrium. Then afterwards there is a diminished equilibrium or imbalance. And that's why you see those subtle changes in the human body. So apparently, I don't know, this is not scientific, but if you read economists, they came up with this U-shaped happiness curve. And apparently, while the middle age you start having a drop in the quality of the tissues and organs, somehow people from the middle age, they seem to be more happier. The reason maybe they know how to handle the stress, probably the family has, they're more settled, they have a certain level of income, they understand the world. Perhaps that could be the reason why the happiness goes up. So it's not always a bad news. You lose something, you gain something, right? So ideally, that's what we all want. Extended healthy years is what is desired by most people, right? So the question is, how do you get that? So that's what basically the crux of my talk, wellness to 100 plus years. So how do you push up that? Perhaps extending the lifespan. So as I said, answer do not lie only in science and engineering. You need both science and engineering as well as social aspects. So you're born with genetics, there is a natural aging, there is a serendipity, whether you want to call it luck or a serendipity, but it plays a role because of a complex organism we are. I'll show you the numbers later. And then the diet plays a big role. Active body, that means physically we're active. The mind is constantly agile and stretched and also peaceful. That contributes to the longevity. And then you have the issue of stress, the work stress, and the sleep. Do you sleep enough properly? Lifestyle, and then injury, that is intentional injury or unintentional injury to your body. That causes. Then the other issues of infections, radiation, ultraviolet radiation and other forms of radiation we get exposed, and the pollution. In fact, if you're exposed to pollution in certain countries, there's a reduction of lifespan by 3 years because of the pollution levels. And then it comes is the medical interventions, medicines, medical devices, organ transplantation, and regenerative medicine. So I'm going to tell you more about regenerative medicine in my lecture. So what we are talking about is the social aspects, lifestyle aspects, and then there is a medical intervention, which is what basically gives you a longer and a healthy life. So in terms of medical intervention, just to give you the basics, so some of you are not into the medical research. Medicines, organ transplantation and medical devices. So there's plenty of medicines, and it's a $1 trillion industry. This industry is exponentially growing, and they even have now medicines for testosterone level controls, menopause they call it. Then comes to the organ transplantation, that is, when an organ is damaged that need to be replaced, you have organ transplantation. So here is the first human organ transplant, which is a kidney transplant, done in 1954, and the guy received Nobel Prize. So 1954 is not a long time ago, given that human beings existed more than 10,000 years. So then later on you have the first heart transplant, 1967, and of course it requires anti-rejection drug. I'm not sure whether you're following the news. This doctor in Italy, Sergio, he's saying 2 years from now he wants to do the head transplant. So you basically want to chop the head and put somebody's head on your body, or take your head and put on somebody else's body. That's precisely what he wants to accomplish. That has been announced recently. I'm not quite sure how successful it be. It's quite challenging, but who knows. He claims, he's a neurosurgeon, by the way, from Italy. So he claims he will be the first one to do the head transplantation, right? Then I just want to show one more real breakthrough advancement. Ella, she has 3 biological parents, right? We debate a lot about biological parents. In her case, she has 3 biological parents. They're basically mothers. You have the nucleus and the donor egg. You remove the nucleus, which defines the individual, and then you replace that particular cell with the mother's egg. Then you fertilize with the father's sperm, and you essentially have cell from somebody, nucleus from somebody, sperm from somebody, and eventually here is a human being. So UK has, I think, allowed this particular procedure, whereas the United States and a few other countries like Australia did not allow it. So you could see the variation, but it's fundamentally 3 biological parents for the same person. That demonstrates the advancements in science and technology, how you can reprogram or re-engineer at the cellular level. And we're going to take these concepts, put in that regenerative medicine for you. So in terms of medical devices, virtually every part in the human body could be replaced. Yeah? And if you look at in terms of numbers, the number of devices, we have now more than 1.5 million medical devices. It's enormous. It's a huge industry worldwide. So 1.5 million medical devices. So you look at the enormity of this. All this require a very high degree of engineering, a very high degree of technology, and a very high level training to the both surgeon as well as the hospitals. And if you notice, 1982, we had the first artificial heart. That's the first time, 1982, total artificial heart. And then nowadays you have bionic eye, and you have the 3D printing. An hour before, I was talking to the students. They were asking about the 3D printed organs. Here is a 3D printed knee replacement. And you have jaw bones. And here is a 3D printed skull for the training the surgeons. They plan the surgery based on these 3D models. So this is a reality. Yeah? And can you imagine such things without a role by engineering? Engineering has to play an enormous role in bringing these ideas to the clinical practice. And of course, you see this person with a prosthetic hand, he's able to perform complicated functions. Yeah, you should say that, putting the lace. And you have a robotic assisted teleway operating in the surgical theaters. It's also being practiced now. and you have a doctor on wheels. It's another excellent example of engineering. And what really got me attention was, now in addition to the heart pacemakers, now they already have a brain pacemakers. So people with epilepsy or certain problems with the movements, they are able to have these pacemakers embedded into the brains, and you could stimulate using electrical signals, and you are able to gain certain movements of the hands and limbs. So that's possible. And now we also have neuroprocesses which are implanted on the spines, which release certain drugs so that they're pain relieving, at the same time stimulating certain neurological functions. So this is again happening now. So the other one is much easier to comprehend, is the nano patches for drug delivery. These are meant for delivering vaccines. Normally vaccines require a more liquid environment, but these are the dry vaccines that could be delivered using a simple nano syringes, and that a patch looks like that. It actually has a packed, medicines are packed inside the syringe and is actually delivered to the patients. And you have sensors now can be embedded into our internal organs to measure information. And you have a diagnostics, a whole range of them. I know some of you, the research that's going on in Birmingham is towards that. And Google and Novartis now talking about contact lenses, which can also monitor the blood sugar levels. And diabetes is one of the major problems in most countries. And having such a device which tells the patient at the same time administer the insulin on demand is really a boon for the patients. So that's a huge opportunity, how technology world is changing the medical practice, right? And then Japan, you always find very interesting application. Here they have a baby nappy, and which sends a signal to the mom. It's better. It's a high time. You better come and attend to me, right? So they have these nappies which give the signals. And down the other side of the English Channel, you have a French company developed similarly based on my kind of technology, what we call electrospray. They produce these nanoparticles. The main thing is some people have born allergies for peanuts, for milk, or dust mites. So how do you sensitize this population is you deliver small doses of exactly the same component, so they develop the resistance. So here is the electrosprayed, these components, antigens that can be delivered via skin. That's been done. Of course, you recognize this gentleman when I have more hair at that time. And we also developed the breathable nanoparticle delivery systems. It's been taken up by companies. This is to deliver vitamin B12 and supplements to the people. So before I jump into the regenerative medicine, I need to take an overview on the medical devices I showed you. Most of these medical devices, they have a limitation in terms of how long they would be very functional. So there is a limited lifespan. Let's say you have a hip joint replacement, that could only last for 15 years. If you have a knee joint replacement, again 10 to 20 years. So after that, if a person is living longer, what would happen? So they had to go for revision surgery, they had to be treated again. So there is a lot of issues involved in terms of these medical devices. So you could go on, look at the several medical devices which are posing serious problems with respect to the long life. So here is an example, for example, heart valve. We have a common problem is calcification. So the heart valve becomes very rigid, so it will lose its elastic function and it becomes much more rigid in terms of opening and closing. So the heart's pumping ability gets limited. So here is the calcified heart valves. Similarly, it's very common to have a stents, and there is a restenosis. That's a reblocking of the blood vessel happens. Again, because of the limitation of the implant. And hip joints, there is a wear and tear, particles come out and they also get into the system of the person. There are the systemic issues involved in terms of the hip joints. In Singapore, we had several cases from a brand well-known company. That implant eventually gave away, and this guy used to have excruciating pain because there's a lot of particles, metal particles coming out. They end up in the bloodstream and they give us side effects. So these are the big challenges for the current medical devices. So that leads us to basically regeneration. Regeneration means, in a simple terms, you are regenerating damaged or affected tissues and organs. So it is considered as a holy grail of medicine, and it's a holy grail means not much has been achieved, more need to be done. So I give you some examples here. What you see here is a child with a small injury. So it's natural, you leave it alone, that injury heals by itself. Same way, you have a burn, very small burns on the skin. With time, let's say 2 weeks later, maybe 4 weeks later, it will heal it by itself. So you look at bone, even bone fractures. I had one bone fracture on my elbow. I was playing squash and I had it. Nothing I really did. I basically immobilized it, and after 3 months, it's back to normal. So fine fractures, finer damage to the tissues, the body has a natural ability to regenerate. Yeah? And sometimes we actually take a cancellous bone graft. We extract it from the cancellous bone. It's very potent with extracellular matrix proteins as well as a lot of biomolecules. These are taken out and injected to the patient, the same patient, and it helps in terms of regeneration. So this is a common practice in the hospitals now. So there's also one more procedure called PRP procedure. If you walk into the hospitals, PRP procedure is common. If you ask for it, what they do is they take a blood from you and they enrich it. So they isolate platelets. Platelets are basically biomolecules, certain biological function. So you enrich them and then you inject it back to the site where the injury is. So when the injury is smaller and which can be managed, this is one of the clinical practice. So what you are basically doing is you are helping regeneration of the damaged tissue. So that's what you're doing in this procedure. This is a standard medical care right now. So what happens now is when you have tissues, the damage is more extensive. And I have an expert on skin burns here. I have to be very careful what I say. But if you have extensive wound damage, it doesn't heal by itself. So you need an external help. And that's where the tissue engineering or regenerative medicine comes in. And similarly, that our regenerative ability diminishes with age. So here is a cartoon. This is a salamander, which can regenerate itself even in its old age. So if you sever a limb of, say, salamander, even its advanced age, it grows back. But the same thing would not happen to a human being. So our regenerative ability diminishes with the time. So that's one of the problems. If you take a baby, and if baby has, say, less than 3 months old baby, if for some reason that baby's hands cut off, it will regrow. It happens. But the same thing cannot happen to the really grown-up adult, right? So that regenerative potential is only there in the very early stages. It doesn't happen after that. That's an issue. So recuperation of damaged tissues, reversing aging of tissues and organs is the holy grail of the medicine. So here is an example for you, a salamander, and here they show if you chop one of the hand, it grows back again. You chop the heart, it will grow back again. Same with other tissues. So some of these creatures have the regenerative ability and they retain it for a long time. Some reason, because of the natural aging that happens in the human beings, we lose that potential. And that's where the regenerative medicine comes in. So what we do is basically we understand cells are the smallest living units within the body, and they are capable of doing a lot of things. Yet, they cannot do a lot of things by themselves. They need a right ecosystem or conditions for them to behave the way we want them to behave. So that's what we call regenerative biomaterials. Cells are basically the engines of the body. And creating the right conditions means in vivo conditions of a human body. We create those conditions, we bring them all together, and that's basically regeneration of the tissues and organs. So that's the basic concept, how we proceed or approach regeneration of tissues and organs. So now I go from there, what are the basic concepts? So you isolate the cells from the human beings. You could have an organ harvested from animal, and then you remove all the cellular components, you put these cells, and then you grow the organ. That's one way. And the other way is you take stem cells, you isolate from the patient, and you culture them, and these stem cells excrete their own extracellular matrix, and then you organize that, and then later on populate with the cells, and then you differentiate those cells into different tissues and organs. And Professor Liam actually does a lot of work in this direction as well. So what do you see there? Brain, I wish it is a brain. It's a fat. It's a fat tissue. So, the fat tissue has a yellow color. And so while we have a negative aspect of fat, you could isolate some useful cells, stem cells from the fat nowadays. There are people working on isolating stem cells from the fat and using them to recreate tissues and organs. So even the fat is not unwanted. It is useful now for our research and progress. So what we do as an engineers is, instead of relying on all those natural matrices, we create synthetic matrices using some of the technologies. And then idea is these particular three-dimensionally organized synthetic matrices would help to support the cells, to differentiate the stem cells, also to provide a right ecosystem so that you can regenerate tissues. And hopefully eventually you can regenerate the organs. That's how the tissue engineering research pursued using advanced engineering principles. So I show you one example. So in the past, we were basically using biomaterials. We moved to the regenerative biomaterials, and this is more detail. I won't go into the detail. I want to show you this one, why we engineer the materials. Lymphets. Have you heard this story? This is an excellent story, just came out recently from UK. So the lymphets are the one, they survive on the rocks, and they scrape the rocks and they survive. Yeah? So how do they scrape? If you see the lymphet teeth, they are like that. This is the lymphet, lymphet teeth. Asa Barber from University of Portsmouth, she made headlines recently because she said these teeth are the strongest natural material, stronger, tougher than silk, naturally occurring material. A small organism like that, a lymphet, it has the teeth which are really able to scrape the rocks and they could survive. So nature has fantastic examples. So now I go deep inside the lymphet teeth. What do you find? So inside this lymphet teeth, you actually find nanofibers. So nanofibers of iron oxide, what we call geothite. So somehow this organism has a teeth which are very strong, and that comes because it has a geotight reinforcing nanofibers embedded in a chitin matrix. That's why the teeth are very strong and very tough. So that excellent mechanical property is derived from the microstructure engineered at the nano level. That's the point. So the question is, if I'm trying to attempt a regeneration of the tissues, I need to mimic these particular natural structures. So that's what we do. So here is an example of the length scales, a paper which you are very familiar, red blood cells, bacteria and viruses. These are the fibers, for example, all our shirts or the dresses are made of these kind of fibers, which would be typically 10 to 15 microns, and paper thickness is about 100 microns. So now if you look at our own bones, our own tissues, we are made of collagen fibers which have a dimensions of 100 nanometers to 5,000 nanometers. That's the size dimension. So collagen fibrils are even smaller. The question is, can we synthetically produce nanofibers of that dimensions and control the properties so that we can use them as a scaffolds for hosting the cells and produce the tissues and organs. So here is an example. So bioabsorbable biomimetic nanomicrofibers, about 50 to 100, 200 nanometers thickness, diameter. So that's the goal. So you have 3D printing and electrospinning are one of the possible options. I work a lot on electrospinning, so I show you an example of electrospinning. This is more into molecular biology aspects. I won't go into that because of the time constraint. So I take an example of a heart and I explain how we apply this concept in regenerating the heart. That would be basically an example I want to illustrate. Why heart? Because heart need to function 7/24 hours. And you do not want heart to rest, right? If heart takes rest, you know what will happen. So brain can probably take some rest, but not the heart. So it's a very important organ in the human body, heart. So we monitor it very carefully now. There are so many devices to monitor 7/24 hours. Yet, you have a scenario of heart attack where the blood vessels, because of the plaque formation, the blood supply to the apical end of the heart is constrained. What that means is heart is no longer receiving, heart muscle is no longer receiving nutrients and oxygen. So what happens is that particular part of the heart actually dies. And when it dies, the heart wall thickness becomes thinner and thinner. So it becomes very thin. When the heart wall becomes very thin, it will not be able to pump blood that is necessary for your survival. So that is a symptom of heart attack. Once you have a heart attack, when it is very severe, the heart is no longer able to pump the blood that is needed for the heart, needed for the rest of the body. And that's why that person is not able to walk, not able to do strenuous things. Eventually he may die. So how do you now address this issue? You had asked one fundamental question. Have you ever heard of cancer in the heart? No. Mostly you talk about cancer in the blood, you talk about cancer in the bone, you talk about cancer in pancreas, all other organs. But you rarely hear about cancer in the heart. What is cancer? Cancer is basically unrestricted proliferation of cells. Some reason heart cells, heart muscle cells do not have cancer. That means they do not have the ability to reproduce themselves. That means that's the very difficult challenge to regenerate because it naturally do not have that ability because you don't find cancer in the heart, right? So how do you address this issue? So this is where we tackle. So we take the heart, then here comes our electrospinning, and we produce the fibers, place them on the heart. So a technique is very simple. So it's a process where we apply voltage and we produce these fibers, but we can control these fibers. And I have excellent students who does a lot of magic with these fibers. And once you produce those fibers, I will go very fast, I'll just show you the results. There are a lot of detailed studies that have been done. So this is a pig model where we actually create an artificial heart attack into the pig, and then we place this particular electrospun, carefully designed nanofiber matrix, and we stitch it on the heart after the heart attack. So then what you see is the heart echocardiograph. This is a healthy heart. You see the fluctuation, heart beating. After the heart attack, it becomes flat. That means heart is not able to function properly. So after you place this nanofiber patch, which is already engineered, onto the infarcted heart, it regains its ability to function. So you see that striations in echocardiogram, it comes back. So what it tells is we are able to help the heart, which has actually undergone for a severe heart attack, to regenerate itself. So here is a lot more evidence. We look at the ejection fraction, fractional shortening. We look at the cross-section of the heart. We look at the blood vessel formation, a very detailed study involving lots of students and scientists. So if this works, so what you see is it's a beating cardiomyocytes. So we are getting them to beat like the heartbeat. So these synthetic nanofibers engineered at that nano level are able to provide a right environment so that the heart cells are able to function the way they should function. So that's the whole outcome of this particular research. So I'm just illustrating an example using heart as one case, using electrospun nanofibers. But there are many technologies, there are many engineers, there are many scientists pursuing these directions, and they are making great advances. And you see here, this is the electrospun trachea implanted into the humans who has a problem with the tracheal cancer. And generally, if someone has this issue, they would not be able to have a good speech ability, and it is regained having that particular synthetic grafts. So it's actually done on the human patients. As I said, there are many scientists and engineers across the world now looking at different human organs, different human tissues, and you probably can name it, almost every tissue in the human body being attempted by regeneration of them. So this is how research is advancing. And I like this particular one. Somebody, they produce mini brains using the similar concepts. It's a brain, but it's a mini brain, has been done in the laboratory. I like this one even more. This is a synthetic meat, and this is electrospun protein carriers. So they put the cells on it, they grow, and eventually the goal is to make it almost taste like a meat. But you're not sacrificing animal. It's completely synthetic, and it's grown in the laboratory. So here is a tissue engineered meat, and there is a company in California called Impossible Foods. They're trying to make this artificial meat using similar concepts, using a plant-derived materials. So there is no animal that is sacrificed, but they're trying to recreate the taste of a blood, the taste of cooking a burger, how it tastes after you cook it. So it's wonderful how these science and technology advancements leading to unintended useful things for the human beings. Yeah. So as I see some young people in the audience of probably the future scientists, if I had to talk about in a big picture way, the medical devices as of now, this is what they are. In the future, they would be multifunctional, and they would slow down aging via regeneration, perhaps reprogramming of cells, which many others are working. And this is my last slide. In my opinion, modern medicine is about 200 years old, and regenerative medicine is still emerging. longevity with health is now possible, but of course you can realize it with innovations in regenerative medicine, medical devices, and advances in biomaterial science and engineering. Universal longevity, that means every human being on the planet, that's 7 billion people living to 100 plus years, is a distant dream. It's not going to happen so soon, but the quest for longevity is the one drives innovation around the world. And I just want to say why regeneration process is so complex is because you have trillions of biomolecules in our body, you have trillions of cells, several tissue types and organs. So all these things have to work in equilibrium, and that's highly complex. And I showed in my previous, the beginning of the lecture, so many variables are involved: genetics, lifestyle, the food choices, nutrition, and medical intervention. All these things play a role in defining, setting that equilibrium, which eventually gives you a longer life. So if you want long life, at the end of the lecture, that's what we all need to do: a good sleep. Because good sleep helps us to clean up the brain, regenerate our body. I think a good sleep is what I think is necessary even after the jet lag too. Thank you again for your attention. It was wonderful giving this lecture to you. Thank you. So there's two things that have been highly advocated by the commercial world. One is the supplements, the other one is antioxidants. Scientific literature over the time has not given a conclusive evidence of the benefits of either antioxidants, neither the supplements. So, but there is something called placebo effect. That is, if you believe in it, somehow your mind thinks it is gaining the benefit, and that has certain level of benefit. So if you are looking at gaining few years, like 3 to 5 years, having that strong belief supplements are going to help you, it's a belief. In terms of real scientific solid evidence, it doesn't exist yet, because when they did a long-term studies, what they found is there's no real correlation. You're taking supplements, but how is this actually getting absorbed by the system? Mostly you're taking orally, and these supplements going through your digestive tract. But from there to get into your various tissues and organs, it has to go through several layers. So this absorption process is not guaranteed. So while the absorption process and mechanisms are not very well guaranteed, so there's no way you can actually see that it is actually giving you evidence. So the same goes with antioxidants as well. So while I say that, I would not discourage you from taking antioxidants and supplements, because there is a placebo effect, if you believe it. And you remember the red wine, chocolates, they promote it so strongly because they say red wine has antioxidants. You take it, and we all love to take at least one glass of red wine. And I'm going to ask at the dinner, I need a red wine. Even though I don't totally believe it, I have no other option. So I just take it. So my answer is, from the scientific aspects, it is not conclusive. From the social, more the way our mind works, why not? But if you're going to spend a good proportion of your salary on antioxidants and supplements, I advise you not to. Because there's a lot of people do that. In fact, in Asia, I know, they advertise and the supplements, you worth it, you deserve it. So if you're a hard-working professional, what would you do at the end of the day? You said, I worth it, I need it. So you go and pick it up from the shelf, you buy it. Because it is marketed so strongly and so well, it appeals to you. Because you are working very hard. At the end of it, you want to feel good. I worked hard, I must treat myself. So how do you treat yourself? Is to have that bottle with you and say, yes, I deserve it. So this is how the marketing is done. So I guess that's the real world. What we had done, some work, is we put the supplements into our scaffold systems, like curcumins and things. What we have seen so far is they have a very good antibacterial and anti-viral properties. So when I have those, that means they would change my inflammatory characteristics. When it changes my inflammatory characteristics, it might help in regeneration. So there is a long path to it. Because one of the issues with regeneration is inflammation. You are competing with that. So the inflammation process, if that can be modulated by these particular supplements, you are kind of going through the back door, and so there is an angle there. That's a tough question, because I also do not know why they do not regenerate. Only one thing we can guess is there are a few cells in the human body. They are like nerve cells as well, neurons. Also much difficult to regenerate compared to, say, red blood cells. It's very easy to replenish red blood cells, white blood cells. But when it comes to heart muscle cells and neurons, it's much difficult. Could be the reason is they are much later differentiated cells, and maybe along the process stem cells somehow forgot how to do that repeatedly once the aging process starts. It's only guess. We also do not know. So my answer is both, because it is clear that lifestyle, work stress, they contribute to your longevity, no doubt about it. At the same time, medical interventions also helps you, because you are interrogating the damages, which is getting accumulated in the body with time. So you have an accumulated damage that's happening, that need to be taken care by medical interventions. That's where all the science and technology advancements come in. But while you are solving that one, there is other fundamental issues that accumulation of damage is happening routinely, that comes out of stress, lifestyle, food choices you make. So all that, the emotional part, the way your brain thinks about yourself, the positive attitude, that has a significant role as well. So there was a study, they looked at people living up to 100, 120. They actually interviewed these guys. They live in Okinawa, they live in part in Italy, there's California, what they call blue zones. What they found is these guys are totally stress-free, and they enjoy the life. They do physical work, they also do kind of mental work, but not so deep. And they don't have so much medical intervention, and they have good genes, of course. So that is giving them the longer life. But most of us cannot choose that lifestyle because we work wherever we are working. So you're going to have accumulated damage anyway. So once you have that, you need a medical intervention. So that's why you need both for the longevity. So yeah, that's a challenging question. So what Liam is saying is, you could choose to have prosthetic limbs which enhances your performance. So it's almost like exoskeletons. They design exoskeletons so that you can jump much distances, you can run faster, and probably you can do other activities even better. So when it gives unfair advantage to individuals, I think it becomes ethical issue. And I think the humanity has not gotten to a point of debating that one. But I think when people start seeing particular section of the humanity taking advantage of it, and that is imbalance creates, I think there will be concern. And I think that would pose an ethical dimension and need to be debated. So that's kind of an issue. a problem like longevity, it falls on both the aspects. You have a social dimension, you also have a technological dimension. And some reason, because of the deep knowledge assets we need to progress in each of those domains, our engineers, scientists are silo mentality. So is the arts and social scientists. So getting them talking to each other, exchanging, respecting the views is very much necessary for future designing these devices and procedures. So some level of understanding of the other aspect is very helpful. And how do we encourage this young generation to do so is probably the way we design our lecture classrooms and the way we can mix these students and also give them an opportunity to work on projects collectively across the disciplines. So that's probably the way to go forward. And so that requires revising curriculums, revising our the way we are organized as a universities, and then the way the students are being told. This is how I normally mentor my students. I tell them one thing, you really do not know how long you're going to live, but if I say you're going to live up to 100 years, there's no hurry. Why don't you learn things in a way that would make a huge difference to you? I tell them that. The second one I also tell them is, if you ask anybody, how many friends do you have? Mostly the answer would be 1 to 5, the good friends. The friends you can rely on, deep friends, strong friends. General answer across the world, I did that same thing like this same, how long you want to live. I did this one more analysis myself and I asked around. The answer is 1 to 5. Whether the person is introvert or extrovert, the good friends, strong friends. So now, I tell my students is this way, in the whole world there are 7+ billion people, but you only have 1 to 5 friends anyway. Why don't you try and shake hands with others and then just have a certain degree of comfort, just understanding their way of thinking. And the life becomes more enriching and wonderful. And sometimes they buy it, sometimes they don't buy it. And those who don't buy it, I just tell them, think about it. So I think it will be very enriching to have that cross-disciplinary, boundaries. That interaction is what's going to make things much more interesting and exciting. And I hope they do that. I can only hope. Yeah.
Okay, thank you very much. So I'm conscious of time, so I'd just like to finish off by proposing a vote of thanks to Professor Ramakrishna for an absolutely fantastic talk. Thank you very much.